It's my pleasure to welcome our distinguished seminar speaker today, Dr. Tom Ball from Microsoft Research. So for those of you who had to slog through the Ball-Laris paper, you have him to blame for half of that.
It was a joy to read.
He's also been very influential in bringing in software model checking to within Microsoft. He's been at Microsoft from 1999. He tells me that he is from the Midwest. He got his PhD from the University of Wisconsin at Madison, so he's used to this kind of weather. And he's going to talk about something which I think is fairly new. I haven't seen this work too much before. Tom?
Thank you, Saurabh. It's great to be back. Yeah, I was born in New York City, but I've been working my way west, and I was in Madison, Wisconsin for my PhD, and I was in Bell Labs in Naperville, Illinois, outside Chicago for 6 years. And then I've been on the West Coast. So it's great. I flew into Indianapolis, and I asked for I'm very, I like to save gasoline, and I had been in New Jersey and they gave me a Toyota Prius. So I said, do you have a Prius? Because I like driving it. They said, no, but we have a Mustang. I was like, okay, I was green out on the East Coast. I might as well, so I had this white Mustang that I drove up last night, and this morning in the parking lot, I was like, where is it? So it's fun to be back in the Midwest and sloshing through the slush. So this is work that's a real team effort, anchored by Nikolai Tillman, who proposed the idea and really got it off the ground, and a whole team of people that are in the research and software engineering group that I co-manage with Ben Zorn at Microsoft Research. So Sebastian Burkhardt, Pele Dehelu, Michal Moskal, and Nikolai Tillman, and I nibble around the edges, but as you'll see, I'm a fairly dangerous coder, and we are going to do some coding together in this lecture. So the title that I sent to Saurabh has this sort of pretentious marketing spin, productive scripting on and for mobile devices and web services. But I'm really a programming language person and a computer scientist. We like to reduce things to fundamentals. So I came up with what I thought was a better title that is sort of about self-reflection. And it's creating X apps with X, where X is mobile and cloud. So the idea, is if you're going to develop mobile plus cloud apps, why not use mobile plus cloud to develop the mobile plus cloud apps? I think whenever one is trying to develop for a particular domain, it's best to develop in that domain so you sort of feel the pain. Or as they used to say at the Microsoft, eating your own dog food, which I think has gone out of favor, but that's what they used to say. So this is the title, and if it's mysterious to you about this recursive sort of definition, hopefully at the end I will convince you that with TouchDevelop we are able to achieve this sort of vision. So what do I mean by mobile plus cloud? So there's this paradigm shift that's well underway for the last decade from single computers that we have chained to our desk or carry around to many mobile devices that we juggle. And these mobile devices have data connections, they're almost always on, and there's this cloud, and that cloud is a huge set of clusters, essentially, all over the world, many data centers, right? And a prototypical app is something like we've had with the Kindle for many years. You download the books you like, but then that app is interactive. You can annotate, it knows where you are, and then when you go to different devices, it remembers all that. So how does that happen? Well, all the state goes into the cloud, right? So the device, the mobile device, you make your annotations, and there's this huge cluster which is aggregating all the books everybody's reading and all the annotations. And then when you go to a different device, you're just attached, and all the knowledge that you have about the books you're reading, the annotations, where you are, roams with you. And perhaps that can be used for nefarious purposes like knowing exactly what you're reading at what time, but it's also tremendously convenient because you can have your Kindle and then you can be on a laptop or you can be somewhere else, and it's a seamless experience. So this is part of the definition of mobile plus cloud, although it focuses sort of more on the cloud as a data storage whereas we also think of it as compute. In general, a mobile plus cloud app is a form of a distributed system, right? And so the generalization of this Kindle scenario with a single user, we go to something like Facebook, right? Or where you have multiple users simultaneously accessing the cloud through many devices. And as we know, Facebook's a huge distributed system worldwide, coordinating all these feeds and a tremendous engineering effort to make this happen. So code is executing on everything, all these devices, and in the cloud simultaneously to provide one sort of social experience for what now, hundreds of millions of people? Are we approaching a billion? I can't remember the numbers with Facebook. So one question is, well, how would we make it easy to program, maybe not Facebook, but a small social app that we want to put on all the devices and then have them coordinated through the cloud? It's not a simple matter these days, although there's lots of good infrastructure out there. And so TouchDevelop, what it is a mobile plus cloud app that I'll demonstrate to you that has sort of four major components. The first is it's a social cloud of programmers, scripts, users of those programs, the data we collect about the programs, the bugs they have. So like a Kindle will put the books in the cloud and the annotations. We're going to put all the software engineering artifacts in the cloud and make them available to everybody. The second thing is we want to go cross-platform, so we have an integrated development environment that's browser-based. Okay, so it's browser-based, and it can run on your laptop or a desktop, and you can use a keyboard. But it also works if you're on a smartphone. So if you're on the bus and you're working on a little script, you can take out your smartphone and you can code. And so we've optimized this integrated development environment for mobile devices, which means no physical keyboard. We assume you don't have a physical keyboard. If you do, that's a bonus. We'll use it. But if it's not there, we're going to do something nice for you. And the way we do that something nice is we give you a programming language that's a sort of simple, safe scripting language. It has static types, and as you'll see, the static type system helps make it easy to program with a single finger. No curly braces, no dynamic types. We want to know, based on where you're pointing in the code, sort of what you're likely to want to do next, and to help you code very, very quickly and efficiently. And of course, any language is nothing without a set of libraries. So if you're on a device, we have platform libraries that abstract the platform. You can get to GPS, you can get to your media library, and also we have web services you can get to, and we also have the ability to define user-defined libraries. So we want users in the TouchDevelop ecosystem to create libraries themselves. And the whole idea is, using all these four parts, we're going to allow you to create mobile plus cloud apps. Okay? So in the rest of the talk, I'm going to go through essentially these 4 points. We'll talk about the cloud, we'll talk about the IDE, we'll talk about the language and some of its novel aspects, and then some of the libraries. So that's sort of the high-level overview of TouchDevelop and where we're going. Okay. Any questions so far? Yeah.
Previous slide. So I want to understand sort of the new pieces. So
yeah, we're going to get to that. So let me dive in. So a lot of this might look familiar, like, oh, I can program in a web browser. Yeah, there's lots of Python, and I can use GitHub to store versions and that. I think it'll become clear as we go there. I would say that the most novel part is probably in the programming languages. Other parts you will have seen, but we'll get to that. So let's talk about the cloud, and the best way to do that is to just go to TouchDevelop.com. And
one other question.
Yeah. Mm-hmm.
That's like, is static type scripts, is that considered a serious limitation, or is that acceptable? I don't have a sense of.
Well, let's talk about that. I mean, I think it's better to see some examples, and then we can chat about that. Okay, so what you can do is go. You can follow along with me. At some point, I will like you to go to TouchDevelop.com. If you do that, the homepage looks like this, and you can click on open the web application. For the optimal experience throughout the whole lecture, it's great if you can log in. You don't have to log in, but some of the features work better if you're logged in. You can log in with a Facebook account, Gmail, Yahoo, whatever. So what you see here is the TouchDevelop hub. So as I said, it's a cloud. It runs, we back all the data onto Azure. And let's look at the first thing. So the first thing is people can share their scripts. And if you've been reading the news, there was this guy who created this silly app called Flappy Bird, right? And then took it off of the iPhone. And then this caused a huge bonus for every development environment, because everybody went and said, I need to create Flappy Bird. And so like, if you look at our top scripts right now, everybody came to TouchDevelop and said, oh, we got to create a Flappy Bird. And one of the best ones was done by this guy, Zach. So I click on that icon, and it basically lets me run Flappy Bird. And if you haven't seen Flappy Bird, it's a silly little game that's nearly impossible to play, where you touch in the bird, you try to get through the pipe, you try to keep the bird. I got through one, yeah, I got through two. Okay, and then when you touch the pipe, you die. So that's not particularly novel. I mean, we have a game board, we have Flappy Bird, people writing Flappy Bird. But what's interesting is, look at the data. It's a social experience. We see sort of, Zach created this 23 days ago. We see how many users. So what does that mean? How many users actually clicked the run button? So there were 1,600 unique users who logged into TouchDevelop and then clicked the run button, but they ran it quite a few more times, right? We have a like, we have likes, we can edit it. So I'm not going to go into this in detail right now, but the text, when you create a program and put it into TouchDevelop, into the cloud, it's available, it's open source, right? Anybody can read it, anybody can take that program, and they can modify it. And in fact, you see, Zach's script is quite popular because there are 28 plus variations on it. So one way students learn and people learn how to code is they apprentice, which means they look at other people's programs and they use them. So if we click on those variations, we see Flappy Bird, Jumpy Sparking, some ones I'm not going to name, but if we load more, there was one that I really liked called Flappy Creeper. And now we look at that one, that was created 9 days ago, and if I run that one, it loads and runs, and it's a little creeper like from Minecraft, I guess. And he also changed the icons. Now we have a diff to base, so if you're really wondering, well, what did this guy do with respect to Zach's code? We put diff right in the thing. So you see we have version control. We have a lot of the features that you expect sort of in an IDE, but we present it to the users, and here you can go through the diffs and see that pretty much what this user did was just change the images, right? They didn't really change any of the logic of the code, right? So the idea of the cloud is that we can persist. We can persist the programs, we can do version control, that's not particularly new. But we can also record every time that program is downloaded, we download it into the TouchDevelop IDE, which I'll talk about later, and we have that IDE instrumented, so every time somebody runs, we send a little message back to the cloud. And so we are actually linking up programmers with their users, right? We're providing a service to the programmers. And in fact, we do more than that. We do, for example, crowdsourced code coverage. So what's code coverage? Code coverage is available in a lot of IDEs. You have a set of tests. You want to know which statements were executed and not executed. You enable code coverage. You run it. You see which statements were executed. Well, we do this automatically on behalf of programmers by just sampling. So user clicks the run button. We toss a coin. If it comes up heads, we insert probes in the JavaScript we generate. I didn't mention that, but we compile in the browser from TouchDevelop into JavaScript. We run it on the client. The probes execute. We get a set of statements that were executed. We ship it back to the cloud. And then you can see here, we had 2,700 runs by 1,200 users that contributed coverage data. We took all those covered statements, we merged them together, and we present them in the IDE. And this light blue, which is barely visible, means the statements were covered. And in fact, this game is so simple, I think Zach has 100% code coverage. But people also find bugs, right? So we have a bug reporting mechanism, right? So there were 6 runs which failed in the action endgame. And we actually have a stack trace, and we do some collection of data. There's an idea of cooperative bug isolation from Ben Liblet. We implemented that. So this whole idea of putting a program in the cloud is not just to store versions, but it's also to see when it's run and to collect the data. Because just the business of the cloud is to connect users, right, with data or computation, I think in a meaningful way, to get a tight feedback loop. And that's what we're really attempting to do with our cloud. Okay, so that's just a very quick overview. So what I've shown you is that, I guess I didn't show you that. Yeah, well, we'll see that in a little bit. So one of the things, I didn't create a program, but programs actually move with you. So as you're editing programs, and I'll demo that in the next section, when you edit a program on your touch device or your smartphone, and then you go over to your laptop, it's just like with the Kindle. You're editing the same set of programs. If you're authenticated, your programs move with you, and you can edit and run from any device. What you've seen is that you can publish the programs to the cloud. So when you're ready, your private little program you've been editing, you publish it to the cloud. It's uniquely identified for all time. It's sort of interesting. If you look at Zach's program, there, it has a funny little ID. NHBR, that's a unique small signature. And if you go to touchdevelop.com / that little thing, it's there. And as long as touchdevelop.com is alive, that version of the program is there, and you can't modify it. So if Zach wants to change it, he has to make a new version. And when he publishes that, we record the provenance. So we tell the users, hey, there's a new update. Zach updated his program. Okay. So that's the idea. When you publish, just sort of like on Facebook, the good part is it's always there, and the cloud never forgets. Anyone, as you see, can run or edit a published program. The provenance is tracked, and we have a scoring system where we give kudos back to the programmer who created a popular program. And popularity is measured by the number of runs, the number of users who've edited it and made new versions. And then the final thing is that you see we collect a huge amount of data that's associated with your program. The coverage data, the crashes, the bug reports. Question?
So is there a way for programmers to make money off this?
Very good question. And the answer is yes. And that wasn't going to be something I went into. But Zach, if he wants to make money, he can go and he can export his script to an app. Right? And right now, we focus on Windows, although you can make just a web app out of it. But we export, and we have different backends in the cloud. We compile for Windows Phone and Windows. And we are considering other more popular platforms right now. So people are monetizing it. We have a little ad plugin, so you can do ad monetized apps. And if you go to touchdevelop.com, you can actually see we know which apps in the store came from TouchDevelop, and you can see here. So we have about, it's not huge compared to, say, Android, but, for a little research experiment, we have 90,000 scripts published to the TouchDevelop hub, and this, over 800 apps exported.
So basically, everything you submit is open source, right?
That's correct.
So how do you protect the IP of some, the games developed by some programmer?
Yes, well, it's open, so that person, you can read our privacy our whole policy. You put code in there. The first thing is if you're going to try to monetize it, it's your business about making sure that you're not bringing other people's code into the system. But then you have recourse outside of our. We don't do anything else. It's open source. You have the right to take it and try to monetize it, but other people also, that whole, we give you the right to go and publish it to the App Store. And whatever feuds you're going to get into with other TouchDevelop users, it's sort of the same as open source, right? We have the bazaar for you, and we give you all these things. But yeah, we will we do have sort of notions of groups, and we may have a notion of private publishing, but again, this is a science experiment to start with, and so we've tried to make it as open as possible. But yes, there will be many sort of interesting issues if we become more popular that we're going to have to deal with. Yeah, another question.
So, for different devices, do you create different JavaScripts? Because obviously the form factors are different.
Yeah, we'll talk about that when we get to the IDE. But yeah, first of all, there's different browsers have different APIs, and then they also differ a little bit on how they do HTML and JavaScript, although they've gotten much better. So yeah, we look at the browser agent, we do specialization. We also specialize the user interface depending on portrait or landscape and how much you have. We do quite a bit. We're very open. In fact, we're so open, you can get all the information I was just showing you in the hub through REST APIs. So if you go to touchdevelop.com/helps cloud services, pretty much all the scripts are available there. We export the abstract syntax trees as JSON. So everything is web-based, and we have a whole set of APIs that's constantly changing, and all the data is open. So we have academics who are into education, teaching programming, who are looking at the TouchDevelop data. We have a number of people going there. You can click on this. Here's an example of just high-level script data. Oh yeah, and I always forget that IE never wants to show me plain text in the browser for some reason. So I go over to my friend Chrome and pop that in there, and Chrome is very happy to show me. So this is like the first 20 scripts, and I'm not even going to try to read it for you. But we make all the data open as well, so people can write crawlers, go over the data, and we have, as you see, we have scripts, we have users, we have comments, screenshots, reviews, tagging, we have art, we have something called leaderboard. There's a lot available. Run means the execution data we're collecting. So we are attempting to do many things here, but this has been from the start wanting to make it very open. So really, to sum up the cloud, I think the future is in cloud-based software engineering. We're embracing that. If you go to GitHub these days, you see not just version control, there's services to build your artifacts across all different types of machines. There's code coverage. You can use Coverity for static analysis. And we're in that same vein. We want really to connect the dots. And for us, of course, we're language designers, so we're the big dot at the bottom here. And it's important for us as designers of a language and environment to connect with programmers and to support those programmers, the TouchDevelop programmers, to connect with their users. And of course, there's many more users than there are programmers, than there are language designers, which I attempt to show with the pyramid. But I hope I've shown you some of the data about how we connect TouchDevelop users to TouchDevelop programmers. And what I haven't shown you is our whole back end, which we collect data on how TouchDevelop programmers are doing. And we have a whole forum, which I have not shown you. Maybe I can just do that very, very quickly. If I can find IE again. Yeah, if we go back here, people have questions. We have forums. We do all our bug tracking. It's all social. So here are issues. In fact, my ID is this silly rabbit, and you can see here. I found a bug. I put some hashtags in to assign it to another team member, and then we fixed it in some build. And so we have the ability, obviously, to see also, as language designers, which features are being used, which APIs are being used or not used. Bugs, we have a whole bug reporting system, so we know and we have a beta build, and we have a set of beta users. We identify the beta users, again, data-driven, by seeing who's creating the most scripts, and then we ask to put them in the beta program where we ship them new features. So we're using the cloud in multiple ways, and it's really been a fantastic thing to see as we iterate the language design, that we can do that very quickly. Okay. So now, how do we deliver programs and how do we edit them and run them? Let's go back and let's create a tiny little program with TouchDevelop. Okay, and there we are. So fundamentally, we're going to create a script, and I'm going to try to demonstrate programming with a single finger here. We're going to create a blank app, and I want to make it available to all of you. So I want to give it a nice name that you'll remember. So Purdue University Demo. Okay, that's how I'm going to name it and create it. And what we see here is a little IDE. TouchDevelop has many different types of primitives. It has actions, which are like procedures. It has pages, which are actions that are our user interface. They're like HTML pages, sort of, but I'll show you that. We have global variables. It is a scripting language after all. We have resources like pictures and sounds. We have an event language for games. We have user-defined data, which we'll get to, and we actually have user-defined libraries as well. So if we look at this program, we have our main routine. And inside here, when I click, it gives me a virtual keyboard at the bottom. So again, what we do is we try to make it possible. We design the language and the syntax and the semantics so that it's easy to type with a single finger. We don't want people typing identifiers. We don't want people typing curly braces. So we have a combination of syntax-directed editing and token-based editing to create programs. So let's just create a nested loop to print the numbers from 1 to 9. And so the way we're going to do that is we're going to click. Maybe you didn't see that, so let me undo that and use the mouse. That's one of the issues with that. Okay, so here's the mouse pretending in my fingertip. Let me cut that. I click here. In the blue, I get a bunch of the syntax blocks. I click 4, and it just puts the 4 in there. And I can't even edit that variable. It chooses a variable for me, right? And I say, okay, I want I 0 to 3, and I click inside. And I can put another for loop, and it creates another variable name, right? And I go there. Okay, so that's syntax-directed editing. That's not new. That's from the late 70s. The synthesizer generator, many systems, Gandalf had it. But when you have a single finger on a smartphone, really, really useful. So I think it's going to make a comeback. And in fact, you see systems like Scratch, which are fundamentally drag-and-drop direct manipulation of block structure. It is similar to that, except we're cursor-based. So now what we want to do is compute an expression. Doing syntax-directed editing of Boolean and arithmetic expressions is not so fun, so we do token-based editing. Now you'll see the browser has adapted. Since there are variables I and j in scope in this block, I can reference those. So let me take I, and it tells me, oh, that's legal. We have a number here, it doesn't do anything. Well, I want to do I times something. So this is a token-based editing mode, right? And now it paints it red and says, hey, you need to do something else. And so I'll put that something. And now it tells me, oh, legal expression, great. Now I'm going to add something. What am I going to add? J, and then I'll add 1, right? And then now it says, okay, you created that expression, but you're not doing anything with it. So I say, hey, let me store it in a variable. And it creates another variable for me. Now, if I don't like that variable name, I can go and rename it. But the idea is TouchDevelop by default is creating variable names for me. It's completing as much as possible of the code so that I can code with just one finger. I mean, people are really good at this, but what if your one hand is tied behind your back, right? Then you want the more help. And okay, and then we want to do something. Probably we want to display that variable. So we have this thing called post to wall, which is our print statement. Okay, now that's a little TouchDevelop script. Now I can run it. Woohoo! And wow, you can barely see that on the left-hand side, right? It printed it out. And how did it do that? It essentially compiled that TouchDevelop script to JavaScript. So what you've seen so far is we have an IDE. It's got IntelliSense based in it. We have a compiler. It compiles to JavaScript. We also have a debugger. So if you want to know how that program is working, you can hit the debug and then run. Whoops. Let's try that again. Maybe I should set a breakpoint. There's a breakpoint. Now I continue. I get to that breakpoint. I step over. I look at the variable of x. It's 1. I continue again. I step over. I look at the X again, it's 2. Okay, so we've got essentially the basics of an IDE, and it's totally inside your browser, right? All this is happening on the client side. Of course, while I'm doing this, something interesting is happening. Remember the Kindle. Okay, what if, I'm done editing on my laptop, and I go and I'm on the bus, and I'm like, I want to continue editing that script. Well, that's TouchDevelop running in the browser on my Windows phone. So, and here's Purdue University demo, and just to, I'm sorry you can't all see it, but there's the program, right? And what's your name, sir?
Mithuna.
Oh my gosh, how do you spell that?
Mithuna.
That's not too bad. Mithuna. Okay. So what I'm going to do is I'm going to go in here, and I'm going to put a string in here, and the string is Mithuna, right? And that's great. And then I'm going to take your name, and I'm going to, sorry I didn't capitalize the M, and post it to wall. Okay, you see that? Mm-hmm. Right, and I run it. Okay, mm-hmm. Great. Okay, so we did that there. Now I go back here, and something funny should happen. It says syncing done. I hope this works. There we go. So there it is, right? So I just was on the bus with Mithunu, and I said, hey, check out my editor, and I did the code, and all those edits are being synchronized to the cloud, and that lets me go cross-device. But I also have version history, which is pretty fun. Let me see if I can find that easily for you. If I said, oh, I didn't want that, you can see I'm keeping all, this is private, nobody's seeing this but me right now, but I can say, oh, here's what happened 30 seconds ago, right? So I'm taking, as you're editing, I'm taking the diffs, and the deltas, and I'm shipping them to the cloud and saving them for you. And then I'm propagating the diffs across all the devices where you're authenticated.
What's the granularity of the diffs?
It's AST level, statement level. So it's pretty small. Okay, so what I'm going to do is, I'm sorry, Mithuna, I'm going to delete that. And what I'm going to do now is I'm going to publish this, and I'm going to publish it to the cloud, so you can all see it. So if you are on TouchDevelop now, and it doesn't matter if you've authenticated or not, you should be able to just and I'll demo you. Don't forget about that message. Just go to the hub and type. Or if you don't have a phone, go to Seymour here, and then search for Purdue, right? And now you see it comes up with Purdue University demo for me because I have it locally. It should also come up online. Did anybody get it?
Yeah.
Okay, sweet. Okay, good. So that's good because that's going to help tremendously in the demo later. Actually, yeah, if we go over here to new, there it is. Okay, so there it is, Purdue University demo. It's been published with that funny thing, and yeah. So if you go to the new scripts, you should just see it there at the top now. So you don't even have to search for it. Okay. So. IDE. So what you've seen is we have the TouchDevelop language, which is a block-structured imperative language. It's typed, imperative, procedural. We have data structures. We have a module system. We have syntax-directed editing of statements, as I showed you, token-based editing of expressions. The whole IDE is implemented in JavaScript. Actually, it's implemented in TypeScript, which is a superset of JavaScript that adds essentially classes and modules. So if you're developing a big JavaScript program, it's nice to have structuring like you have in Java or C#. So we developed that. So when you go to the web app, you are downloading, I don't know, 60,000 lines of TypeScript and that's the IDE, right? And when you press the run button, we're compiling in browser to JavaScript. And of course, we have in our JavaScript all sorts of adaptations so that it runs on different devices, supports different browsers, different display modes as well. So the IDE has some unique attributes. Most of what you've seen so far is pretty generic. I'll show you some of the other things later on as we get deeper into the programming. So any questions about the IDE? So I've shown you it works cross-platform. We really believe that if we want to democratize programming, the web browser is a great place to do it. And in fact, because of the cloud support and the cross-platform IDE, we've seen a lot of pickup. Our main users for TouchDevelop have been in education to start with. So we have a number of different user communities. One is educators and first-time programmers. So in May of 2013, we did our first app day in the middle schools in the Seattle school district. We had 500 plus students from about 7 middle schools come together in one gym. We had music and dancing, and everybody brought their own devices. And we had these little tiny smartphones, and people were coding for the first time on them. It was really cool. And we've had many follow-up events, and we're doing a bigger app day this year. One of our biggest achievements, though, was to get into the Hour of Code through code.org. If you haven't heard of that, they're a great new organization that's promoting computer science education in the US. In December, they had this goal to have 10 million people start to code, and they really wanted it to be web-based. So TouchDevelop was part of that. In fact, we were one of Microsoft's contributors to there. There were a number of other tools available as well. We were sort of the main web-based one. We have another thing from Microsoft Research called Kodu, which is like in-game programming. And that was really valuable. We actually made use of our AST diffing technology that you saw to give the students who've never programmed the ability to create a little turtle program in a totally guided tutorial. So what is going on here is it's the TouchDevelop editor radically simplified, and it's just the same code, but just a little less shown. There's a program we want them to create which is hidden, and we have the AST of that, and what we're doing is we're creating dynamically an edit script and asking the students to complete some actions. So we're teaching them essentially, what to do, like go to the turtle, move it forward, okay, tap the cursor left, and then if you do the wrong one, it says, we don't think you're quite right, backspace into. So we're doing essentially online diffs of the ASTs, and we have we've instrumented the editor to make all the edit operations, and we get a small edit script that gets you to your goal. So, within like a minute, a student has moved the turtle forward, and they're getting the idea of the syntax-directed editing. Over time, what happens is the hints go away, and we go to a mode which says, please do this statement next. And if they're successful, we sort of get rid of the hints, right? So this is another great demonstration of just sort of the language-based integration, that we can just take many students who've never coded before and just start to introduce them to simple programming. And because the automation of the tutorial is the tutorials are automatically generated, we have many people creating their own tutorials for their own students, because all that they have to do is create a TouchDevelop program they want the students to create and annotate it a little way. So that's been a really nice validation of sort of the cloud plus the IDE. Okay, great. So that's 2 topics down. Yeah.
Tom, so you mentioned that one of your goals was to allow programming from the smartphone itself.
Yeah.
So do you have any stats about how many of the programs, or maybe the popular programs that you have in there, are developed on the smartphone?
Oh yeah, I don't have it with me, but in fact TouchDevelop started as only on the smartphone. It was only on Windows 8. It was a native app to start with. And so we had quite a few users, but it was a very small community, those who had Windows Phone. And we see the user agent. So yeah, we have all that data. I don't know, since we've moved to the browser-based IDE, we now have a much broader range, right? We have people on laptops, iPads, but all that data is available. I'm sorry, I don't have the numbers.
The more popular programs are developed using browser IDEs.
Well, it is. Everything's a browser IDE, whether it's on your smartphone or a tablet. It's the same code running. But I agree with you. Probably the larger a program gets, the more likely it's going to be that it was on maybe something with a keyboard. On the other hand, remember, a lot of the programs are also copied from other programs, which is pretty easy to do in the smartphone, especially if you think of like So you may not count that as programming like the creeper, you know, taking somebody else's program. So I think the smartphone, you may not be doing programming a lot of new program elements or new code, but what you might be doing is fixing bugs, right? So that's another thing we can look into. We can look into, you know, where are people creating the bulk of the code, where are people doing bug fixes from? I find myself doing bug fixes a lot, and I can do a bug fix on my phone and deploy it to my users, right? And that's really handy because I don't have to wait until, you know, I'm in front of my desktop. But it's a very good question, and one, we have the data, but we haven't dug into it.
No, I was going to ask you for you know, the diff with respect to Scratch. It looks like something like that.
Okay, so yes, let's talk about the language. So the design considerations for our language. We obviously chose a familiar imperative block structured language, very simplified compared to something like C# or Java or even JavaScript. And the way we think of it is it's sort of on the path from Scratch to JavaScript in the sense that Scratch is block structures, it's syntax directed with direct manipulation. It's sort of like you bring Lego blocks together. And we actually have a library that shows people how to go from Scratch to TouchDevelop. Because we can do everything in Scratch and TouchDevelop. It's just that our user interface model is quite different. It's cursor based. And we think that we can create much larger programs more easily than with Scratch. So Scratch is great. We like it. And in fact, I will show you something like Scratch towards the end. Hint, hint. We view it as an intermediate step, and it's not JavaScript because it's statically typed. So Scratch is really static typing. We are statically typed too. We think that's good for all these this virtual keyboard. It's good for predicting what to helping the student, right? So touch-friendly syntax and semantics. Static types really helps with our intelligent keyboard because we know the type of a variable. We know the things you're going to likely do with it. So we have like we're talking with the App Inventor folks about an automation to take us from Scratch into TouchDevelop. And we're also, since we compiled the JavaScript, we're also thinking about, you know, what can we do to bring TouchDevelop programmers to JavaScript. The other thing is we want to make, obviously, we want to do more with less code, especially since you're programming with a single finger sometimes. So we have an abstract syntax. This is just to say we have a well-defined language, perhaps. Some formal semantics, maybe not, but actually we'd be happy to work with people on that. I want to focus on two of the really unique language abstractions. So how do we do user interfaces? Because I really haven't shown you that. And we have something called boxes, which is quite unique. And then something called cloud types. And I want to know how much time I have.
It should go on till 11. We can go over by about 10 minutes if people need to leave.
Okie dokie. Okay.
That's fine.
Very good. So what I'm going to do is dive right back to the demo.
We have the room till 11.
Okay. Thanks. So let's go back to the Purdue University demo and actually start to use boxes to make a real user interface out of this. So what are boxes? So boxes is a way to actually carve up my display area into a hierarchy. Think of it as div elements. But I'm not going to write HTML and CSS. I'm inside this action, which is a special action. It's called a page. And so within here, I have something called boxes available to me. And so what I can do here is I can take these two statements and I can put them in this thing called boxed, which sort of looks funny. And then when I run it, I see absolutely no difference, right? So that's also sort of funny. But actually what I've done is I've segmented with this boxed, I actually have created like 9 divs in the HTML, right? Because I have 9 of these dynamically created. And if I click here, you can actually see them. I don't know if you can really see them, but these funny blue lines appear. Now that I have this boxed primitive, I have sort of like a this parameter, and the this parameter is called box. And so this gives me access to all the attributes of the box I'm currently in. And what I can do is start to style it. So let's say I want to set a border, and I want to put an orange border around that. And then I want to make the box a little bigger, so I'm going to set its width. And here I'm going to start typing, as you see, to demonstrate that, yes, it is very nice to have a keyboard. So we're going to set the width. And sometimes the keyboard is responsive and sometimes it's not. The other thing we're going to do is we're going to go back. You can see the token-based editing at work here. I hit backspace, boom, token gone. I can set the height. Okay. That's very interesting. And we can run it again. Okay, so now you see something. I have these orange boxes. The text is not centered, so let's do something about that. And in fact, I don't like all these boxes in line here, so let me extract this to a little style procedure. So I'm just going to extract that so we have a little refactoring. Again, very handy when the program's getting bigger. So within here, we're going to go and we're going to do a line. We're going to set the horizontal align, which is left, but we want to make it center. Notice that was a single click to change it. Now we're going to do vertical align. Okay. Again, we're going to center it. Okay, so nice. So now we have those boxes. They are a little bit close to each other, so we can fix that up maybe with some margins. And we can set the margins. Very interesting. It types some characters and not others. It likes the one, that, okay. I can handle that. Put one, run it. Okay. Now, it doesn't really look like I want it yet, because what I want is really sort of a keypad, right? So now boxes are lexically scoped. So I have another opportunity to put a box around that for loop. So let's do that. And again, I run it, absolutely no difference, right? If I click it, you can sort of see a difference. Well, not really. But there is a new box there, and it's the default layout for the boxes inside a box is vertically aligned. So I just want to make it horizontal layout, right? So I'm going to do horizontal layout, set horizontal layout. Boom, okay. I've got my matrix. So you sort of see what's happening there is within that code, it's running the for loops, and it's creating these boxes, and they're just a hierarchy, and I can style them. And so it's a very simple way to sort of generate HTML, but it's completely integrated in the language. Now, one thing you can't do in that code is you can't update global variables. So this is like taking model state and creating a view. So we actually are enforcing model view controller here. And you might ask, well, how do I make my user interface interactive? So let's do that. Let's create a global variable with type number and call it selected. Right? And let's go back to main. And we can initialize in this section. We can say that variable selected should be 0, but its default value is 0 anyway. And just to demonstrate, if I were in here and I set it to 3 and run, I get a runtime error. We should really do static analysis, but and we do know how to do it. But you can see the message. You can't modify global variables here, okay? Except in a special situation. So what we want to do here is we want to add some conditional code. We want to say, oh, if the current value of the box, the number, if that's equal, if x is equal to the global variable selected, then we want to do something special. We want to take the box and, I don't know, set its background, right? Set the background to something. So we'll set the background to a nice bright color. I happen to like cyan. Let's do that. Okay. Now, it's not going to show us anything right now because selected is 0. So we also need a way to change the value. So we need a handler. And so box has, let's see, untapped. So now this is a little lambda. This lambda is only executed when I click that box, that area in the code. And so it can do anything except create new boxes. So it's sort of it's the controller, it can update the model. And so what I want to do here is just update selected to be the current value of x. And now the runtime, it looks recursive, but it's not, right? The runtime, when it sees this update, it says, oh, I depended on that guy. I need to rerun. So we actually have the whole model view controller in one place where you can sort of see it, which actually is pretty unique if you think of like how XAML and other model view controller paradigms are written. And so, I go here and it doesn't work. Oh, there we go. Okay. So we click around. Great. So let me publish that as well. And so on your browser, you'll see an update or something, and then you can start playing with that. So boxes are a very simplified form of hierarchical user interface. At the end, coming soon, I will show you can do more than simple matrices with them. The boxes have a lot of CSS attributes. There's a lot you can do with them. You can't make nice curves and splines. It is sort of square, but there's a lot you can still do with these boxes. So it's an interesting user interface paradigm supporting model view controller, increment automated update, and there's a PLDI paper about it from 2013. And Sebastian Burkhardt was the lead on that. Okay, any questions about the box? So that was sort of quick. Yeah.
It's not a ball box. It's not a ball box. I think it's a very nice platform. Actually, what how this afternoon do? Should I ask now or ask? Yeah.
Well, maybe in the afternoon because I'm running out of time, and I have one more really big feature to show you. Okay, so remember, I promised that we wanted to create not just apps that ran on your device, but that actually, like the Kindle and like TouchDevelop itself, could synchronize device state, right? So we have something called cloud types, which is again driven by Sebastian Burkhardt, simple abstractions for replicated state with automated synchronization and merging supported by the runtime. And so it's very easy to enable social apps with sharing. I've said this already, TouchDevelop itself is a distributed application. The cloud types abstraction lets you, as a TouchDevelop programmer, get the same power. So you can write apps that run on multiple devices, but synchronize through the cloud with data. And there's many ways to think about distributed applications. This shows sort of different architectures, where at the low level, you just have to write code on every server and every device and synchronize with message passing. Very low level, you have to tolerate failures, network outages. This is not what we want to give programmers in TouchDevelop, but if you're doing a data center, you're programming in that case. Classic web apps, what they're doing is providing, you're generally writing something on the server to do database queries, right? To do updates and queries, you're writing some cloud service, and the mobile apps you're writing code here, so the code here is simpler, and you're sending updates and queries, but if the network goes out, you still have to manage all of that. In replicated shared state, the idea is you have a small database, not like gigabytes, terabytes, that is replicated by the runtime for you. Its primary replicas in the cloud, where all the updates go to, and every device gets its own replica, and that's what we provide you with cloud types. And we allow, if the network is partitioned, you to read and write in your local state, and then when the connection comes back, we synchronize for you. So it's a much simpler abstraction level. There's less code for the TouchDevelop programmer to write and less error handling to do. So the pros of this is you can read and write data at all times, even when you're offline. We can hide the unreliability of network and server. You don't write failure handling code. The con is you don't have sequential consistency anymore. But in reality, this is a reality of mobile apps in the cloud. I mean, you're going to be offline, and you want to still do stuff. So we think, as researchers, this is a good thing because we want to explore what happens when programmers are faced with this. And actually, our weak consistency model is the strongest possible form of eventual consistency. And we have a whole set of papers about the theoretical background there. The basic types, we have primitives, like integers and strings, where we have sets of specialized methods, and you'll see the add method is particularly useful. For just blobs, for any uninterpreted type, we have get and set. We have well-defined semantics for each of those, what it means in the eventual consistency model. But then we do composition. So you can make cloud tables which have cloud integers in them. The tables can be linked to other tables. So you can create actually a little NoSQL database with tables and indices that are linked. We give you a whole little database model in TouchDevelop, and we take care of the hard stuff. Okay, so now, in 5 to 10 minutes, I want to go back and show you, and there's a whole other talk I could give about the semantics and all this, so I'm flying fast here, and I apologize. But what I do want to do is go back and back to our little Purdue University demo. So what I want to do is I want to change this. I want to vote for the most popular number from 1 to 9. So I want you all to have your devices, get ready, and we're going to do this by adding an index. Okay, and this index is going to do, let's see, popular number index, and the key is going to be, I'll just name it x, because x was our variable that ranged from 1 to 9. So it's going to map each number from 1 to 9 to a count. Right? Okay, and now look at this. The index can be temporary. That means its lifetime is only the execution of a single script. It can be local, which means it's persisted on your device, but it doesn't roam with you. Or we can put it in the cloud. So that's all I need to do. I don't need an Azure account. I don't need to know about blobs or EC2 and its data model. I'll just say, put this index in the cloud. Okay, now that index is actually initialized already, and it has a default value for every possible key, logically. And every count, which should be a number, has the value 0. So it maps every key, so I don't have an initialization problem. It exists already in logical space, and every number is mapped to a default count of 0. Okay, now the other thing I want to do is I'm going to, remember this selected. This selected is going to represent our vote. Now I'm going to make it local, which means that you're going to get 1 vote per device. Right? If I made it temporary, you could vote that for every execution, right? I don't want that. I could also put it in the cloud, but then I'd have some user authentication. We don't want to get into user authentication now. Okay, so what is it I need to do then? When you vote, you are going to select the number you are voting for. So we need to go into the popular number index at not 0. Sorry. At x, and we go to the count field, and we are going to add 1 to it. And you might ask, why am I doing it that way? But we'll come back to that in a second. Okay, so that's our vote, but maybe we want to give you the ability to reset your vote because you voted quickly and you wanted to change your mind. So we'll give you a button. And we'll do that with a library. We have a little library which will clear your vote. Right, and what will that do? We'll just copy this down here, paste it, and we need to change. We don't have variable x in scope. We need to take your selected, and we need to undo your vote. Okay, and we only want that button to be there if you have voted. So it better be the case that selected is greater than 0 for the button to appear. And the other thing I better do is I better reset to 0, right? And then the other thing here is I only should allow you to tap if you haven't selected already. So also I should go here and surround that and make that handler's conditional on selected being equal to 0, right? Okay, now that's all good. There's one more thing I need to do, which, since I'm running short on time, I won't go through my various steps, but I need to make sure that the cloud session that I'm going to make available, that I create to put this data in, is available to everybody. Right, not just me. So we have different types of cloud sessions with different access control. Okay, wow, I wrote a lot of code quickly there. I hope you followed that. Let's just run that locally and see if I can do my vote. So I do 5, I clear it. Great. But the problem is I don't see the vote, right? So we better do a little change to actually see that. So the way we're going to do that is we're going to take that box, we're going to select it, we're going to put it in another box. Let's pop the computation of x out and put it in this box. Why don't we style it a little? Actually, no. I'm just going to do a horizontal layout. And then when I'm here, what do I want to do? I probably want a bigger font because I want to make the count more prominent. The way I'm going to do that is set it to 2. And then what is it I want to print? Well, I want to print the actual count of the popular number at index x, at the key x. I want to take that count and I want to post it to wall. Good.
The font is too big.
What happened?
21.
Oh, thank you. Thank you very much. Okay, so you can see the vote that I had there. Oh, I got to vote again. That was my bad. How did that happen? Well, I don't know that I have time to debug that. I thought I created that as local, so that shouldn't have happened. Okay, well, I got 2 votes. Okay, so now what I'm going to do is I'm going to publish that. Okay, and if you can go update your Purdue University demo, we should all be able to vote now. Okay, so let's run that and see what happens. So I've got my vote in there. This is where we really hope all the code is working. And the cloud in the back end, and the IDE. Oh, somebody likes 8. Okay, that's good. Oh, another one for 8. See, people start piling on. This is voting. It's an interesting question. When you vote and you can see everybody else voting, what happens? That's it? That's as many people as we have online? Okay, that's all right. So you keep working on that. You can be doing that while I'm doing something else. And the something else is, so keep voting, please. Vote early, vote often. And let me go back and just say that we have user-defined libraries, and now to end. So we come back to this funny title, right? Creating X applications via X, where X equal mobile plus cloud. So when we're in languages, the question is, does our language have enough power? Does our language X have enough power to write the compiler for that language in the language itself? So can we program TouchDevelop in TouchDevelop? Okay, so what I want to demonstrate to you is that with boxes in this cloud state, the answer is yes. I'm not going to do the full TouchDevelop experience. Okay, well, we still have voting going on. Okay, but if we go, and you can see this too, if we go search for TouchDevelop, TouchDevelop Junior is a program that I created